Let's review the last session regarding load flow equation, and in Gauss-Seidel method, with Gauss-Seidel method, the last equation is this one, and in this equation we have two parts: a new part for update value and the old, and another part with old value. When you calculate new parameters in last iteration, you should substitute in this part, and if you have initial value or old version of parameters, you have to fill this part, and this calculation makes new iteration of voltage, the magnitude, and the angle of voltage in bus I in iteration K plus 1. Okay. In real case, and finding load flow or solving load flow with Gauss-Seidel method in networks type 1, and considering this equation and finding y bus, we try to calculate the iteration number 1 of each buses. But because of the slack bus on bus number 1 and the slack bus voltage is determined, the voltage of slack bus is V1 is 1 with angle of 0 degree. So the finding V1 is not useful because this is determined, and other voltage like V2, V3, V4 and V5 is favorite. And the main formula for finding Vi in iteration K plus 1 is written here. This term is update term, update parameter term, and this part is old parameter term. The initial value or first guess of voltages is iteration 0. The first guess. حدس أولية. حدس means guess. أولية, the first. The first guess or initial value of voltage is 1 with the 0 angle, and SLB voltage is fixed as 1 with 0 angle. let's try v2 in iteration 1. Okay, in v2 in v2 in v2 iteration 1 v2 iteration 1, the car is 0 and you have to fill YII, means Y22 with 4 voltage. In bus 2 we have fill Y22 here. P2 pure injection active power minus JQ injection reactive power on V2 conjugate in 0 or initial value minus V21 V1 minus the yellow part is update parameters, but in the first try we don't have any update or new version of parameters. All of parameters is initial, so the yellow part is ignored and next part is activated. Green part activated. Y23 V3 initial value, V24 V4 initial value, V25 V5 initial value. In the last table we find V2 is okay, Q2 okay, V2 initial value is okay, V2 initial value is 1 with 0 degree, Y21 is fine, also V23, Y24 and Y25. Other value is initial value and V1 is fixed as 1 with 0 angle. All of parameters in this equation is determined and you can find it with using calculator, and V2 with first iteration of V2 is determined here or clear here. Also V3 in first iteration, V4 in first iteration, V5 in first iteration also be determined. After solving the first iteration we have this amount of voltage. V2 first iteration is 0.988 minus J 0.0103 for voltage on bus 2 in first iteration, also iteration 1 in bus 3, iteration 1 in bus 4 and iteration 1 with bus 5. We continue the second iteration, and after 17 iteration the condition of convergence the condition of convergence was Vi in next iteration or new iteration minus Vi in current iteration or last iteration should be less than epsilon. Epsilon is 10 in power of minus 4. After 17 iteration, we catch this convergence condition, or we allow to stop the iteration and calculation. And the final amount of voltages is V2 is here to V5. And this V2 is the final. V2 iteration 17. What is V1? V1 is a fixed as 1 with 0 degree. In final exam, we only want you to calculate the first iteration. Finished. The first iteration must be correct. In this way, I ask you to bring your calculation in the next session for exercise more about these items. Do you have any question? Okay. As you know, the result of load flow equation is voltage. In load flow equation, after many iterations, you can find the final voltage of each buses. For example, we find VI with delta I, Vj with delta J. And other parameters like currents, the power you send to bus J, and the power you received in bus J. The impedance is here, and the current you get in the final buses. In this slide, we want to calculate these sub-items regarding the main items of voltage in each buses. Okay. If we determine the voltage of each bus, you can subtract two neighbor buses voltage and divide on the impedance, and you find the current is flow from voltage from bus I to bus J. This calculation is written here. I from I to J, or minus I from J to I, is Vi minus Vj on Vij, Zij, Ij. This is Zij. All of them is per unit. And you have to pay attention about these parameters all as vector. The vector means vi vector means the vi magnitude with the angle of delta I. These items is vector, not a scalar. A scalar means only the number without any angle. If you have two parameters to describing a number, we have a vector. For example, if a is 5, a is a scalar, but 5 with angle of 10 degree, a is vector. Okay. For finding active power, you can calculate from flow from bus I to bus J. You can use this main equation, S equal to V I conjugate. When you want to find S I to J, it is VI multiple to I conjugate, or I conjugate. It is better to write IJ. All of them is vector. VI vector VI minus VJ on ZIJ. All of them conjugate. And then VI, and then a real part of Sij is Pij plus JQij. Real part of Sij means Pij and is real part of Vi in Vi minus Vj Zij conjugate. You can see here. The reactive power is imaginary part of the terms we write about. Another calculation is finding Sji. Sji is Vj when you want to calculate Sji from J bus, you have to write Vj here. Vj on Iji conjugate. What is Iji? Ji is Vj minus Vi on Zij. And you can find it. Real part is Pji and imaginary part is Qj2I. This item is short type of transmission line. This item is model of medium type. Medium type of transmission line. In medium type, we have to divide the capacitor in the beginning of transmission line and the end of the transmission line with half of whole admittance in this location and half one in the end of transmission line. The series impedance is located as short type of transmission line. And for finding active and reactive power here, we have to calculate the current through this capacitor or current through this capacitor. This calculation is some complex, and we prefer to ignore these parameters and this calculation for you in final exam. Okay. You can find some examples in any books. Any books teach you power flow equation in Gauss-Seidel, for example. There are many examples, but I prefer to make you ready for these examples, and we focus this example in final. Other examples or more examples make you confused, and in next chapters we have many examples and you can confuse more. Please be patient, and in the next session I try to describe other examples or solving other examples for your convenience. Okay. In other items, we have to consider about the Gauss-Seidel method in solving power flow equation is accelerating factor. As you know, the old parameters makes new parameters or old iteration makes new iteration or makes new results. As you know, in the main equation of finding voltage, we uh, try to substitute or replace the new parameters here and the old parameters here. And when you want to V in bus 2 in iteration 1, you have to use V2 in iteration 0 or initial value. And for finding V2 iteration 2, you have to use V2 iteration 1. And the new version or new iteration, new parameters, new iteration or results needs old iteration or new or old parameters like V2 iteration 1. In accelerating parameter, acceleration or accelerating parameter, we change the old one, we change the old parameters to finding or achieving the final amount of V2. For example, in natural procedure, in type 1, in example type 1, we solved in some last minute, V2 in initial value can make new or update of V2 in iteration 1, and after 17 iteration we catch the final value of voltage in bus 2. If I change the old parameters or the last iteration, we can get V2 as a final version, final amount in fewer iteration. For example, if I multiple a parameter like alpha, and for example V2 iteration 2 multiple alpha, we can force the procedure to make the final version, final results immediately. And for example, after 10 iteration, we catch the final results. This alpha called as acceleration multiple. Acceleration multiple. The acceleration multiple applied like this. The subtract of new version of voltage in bus A minus the acceleration form multiple to alpha plus Vi acceleration is Vi acceleration in next iteration. This description we only defined for you, and we don't try to solving any examples to uh, to show about the usage of acceleration, like introduction or introduce for you. Okay, another items is okay. After finding the after finding okay, after finding voltages from that uh, from this equation, it is time to calculate Q. Q for PV bus. In PV bus, P is determined, the magnitude of voltage determined as determined, and QI and the angle is unknown. Unknown. This formula gives you the new iteration of Q, and we have to, after finding the Q in each iteration with the maximum and minimum of possible reactive power limitation after each iteration. After each iteration, we have to check this limitation, and for finding the angle of voltage, in the new version, new iteration, we have to find the angle of these parameters. If you check reactive power and we find that your calculation in the new iteration is more than the maximum number of reactive power, or your finding is less than minimum. In other words, your calculation in iteration k plus 1 is out of this criteria, or your calculation is less than minimum or more than maximum. What do you do here? In this case, we have to fix Q. For example, if your calculation is more than maximum, you have to fix calculation with a maximum and continue the iterations. If your calculation is less than minimum, you have to fix calculation with amount of minimum and continue your calculation like this. Other example is regarding type 2 with ghost cycle. Uh, I suggest some 5 minutes, 5 minutes resting and break, and after that we continue our classes. Okay, in um, for solving the next exercise and the next works or system type 2 with GS, and the difference between type 1 and type 2 is the power plant or generator is connected to bus number 4 and makes bus number 4 as a PV bus. In PV bus, the P and the magnitude of voltage is fixed, and the generators can control the amount of P and active power injected and the voltage of bus of which the generator connected to it. And in bus 4, in bus 4, the magnitude of voltage is fixed on 1 per unit, and the constraint regarding to reactive power, the pure injected reactive power is minus 0.15 and minus 0.2, and the maximum and minimum amount of reactive power, injected reactive power. The minus amount of injected reactive power means that these generators can absorb reactive power, and the positive form of reactive power means the injected reactive power is positive, and the generator in this criteria can inject reactive power. Other initial value for PQ bus V2, V3 and V5. V4 is cancelled because the V4 is PV bus, and V2, V3 and V5 in initial value form is 1 with 0 angle. The initial value and the fixed value of V4 is 1 with 0 angle as a PV bus. Okay, in iteration 1 for PQ buses. PQ buses means bus number 2, number 3, number 5. Number 5. V2, yes, yes, okay. PV bus. S like bus is here. S like bus is here. The first one is S like bus. PV bus is another generator buses called PV buses. Yes. Okay. In PV bus, in PV bus, in PQ bus, excuse me, in PQ bus, bus number 2, 3, and 5, we can find voltage in the iterations with the last formula we introduced. Uh, and you can calculate like this: V2 in first iteration is um, about V1 in a slack bus, V3 in zero iteration or initial value, V4, V5. Okay, in a slack bus, the voltage is fixed. The Y bus array is substitute. Initial value is substitute, and after a calculation, we can get this result as a first iteration of V2. I suggest you to do like this calculation in your home for more exercise, and this is very important to calculate yourself. Okay, uh, another step is finding V3, the first iteration of V3. Q3 or P3 is specified as a PQ bus, and the first iteration of V in bus 3 is here, written here. But V4 is not needed to calculate. V4 is fixed. V4 is fixed, and it is 1 with 1 is 1 per unit. The magnitude of V4. Magnitude of V4. The angle of V4 is unknown. Which parameters of bus number 4 would be determined? The delta I, delta 4 is unknown, and Q4 also is now unknown, and the Q4, to find the Q4, we have used this formula. In this formula, we can use object form of voltage and the old version of voltages. For finding Q4 in this stage of finding Q4, we have new version of V2, new version of V3, but the old version of V5 and V4. We don't have new version of V5 and V4. V4 is fixed. V4, the amount of V4 is fixed, specified, and is 1 with 0 angle. But the old version, only the old version of V5 is accessible. But the new version of V3 and V2 is calculated and is in your hand. And after substitution, these parameters, you can find Q4. The Q4 in first iteration is like this. After finding Q4, it is time to calculating delta 4. Delta 4 in the first iteration, use this equation. This equation is written here. And after filling parameters with the new one and the old one. For example, for finding delta 4, we have to use v1, v2, v3, and v5. Which one has a new version of parameter and which one has an old one? v1 is fixed, 1 with 0. v2 in first iteration is calculated in last stage. Here we have the last version of v2. v3 we have last version of v3 here, and but v5 unfortunately we didn't have any updated form. The last or only value for v5 is initial value. Initial value of v5 is 1 with 0 angle. After calculation with scientific calculator, delta 4 is calculated like this. Do it yourself in your home, please. Do it yourself in your home in non-exam situation. Okay? Do it more or finding skills of calculation or working with calculator. بله. سلام. Excuse me. Okay. Uh, after passing the boss number 4, it is time to calculate the parameters for boss number 5. The boss form number 5 is a PQ bus, and the PQ bus, it's required to finding the voltage in iteration 1. The famous equation for finding voltage is here, but in this equation v5 we have to use the initial value for v5, but v1 is 1 with 0 angle. v2 we have update form of v2, update form of v3, update form of v4. The v4 update is 1 with delta 4 first iteration. That is update 1. Okay, it is here. And after finding and calculate this equation, we find here. And after passing boss 5, I think we finished all of our calculation in first iteration, and after 15 iterations we can get the final value of voltages and Q4, and then it is useful to finding delta 4 in 15 iteration. And I think it is this items is lost here, and we can find for you, but this is not useful in exam or final exam. We only the first iteration we consider to solve by yourself. And after finding these items, it is preferred to find the pure injection of the slack bus, that is main P1 and Q1. The second achievement is active and reactive power in the first and the end of each line. I, J, S, I, J, the first and the end of S, J, I. And the last achievement is active and reactive losses in lines and whole network or whole systems. Active power means R, I, J, R, I, J, I, I, J, I, J, square, three phase. Or reactive power is 3 X, I, J, I, J, square. Okay, the chapter 2 is finished, and in the next session in the class in presence, not virtual class, presence mode, please bring your calculator and we have to try these two examples in with calculator and simulate the final exam in the next sessions. Do you have any questions? Any questions? Thank you for coming in my class and have a nice day and nice week. Goodbye, goodbye, goodbye.